Hi guys, so today we'll be solving this Leetcode problem 153. Find minimum in rotated sorted array. So suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array nums, so this array might become this array if it was rotated 4 times. But if it was rotated 7 times, then we would go back to the way it was. So it says, notice that rotating an array 1 time result in this array. Given the rotated array nums of unique element, return the minimum element of this array. You must write an algorithm that runs in O of log n times. So reading our question, we know that our input is nums of array. And as for our output, it says to return the minimum value of the sorted array that was rotated certain amount of times. Okay, so our constraint here, it says, is that it runs in O log n times. And our edge case could be nums dot length could be just 1. That means we return nums 0. And if it is empty equals to 0, then we'll just return 0. So let's take care of the edge case first, and then we'll talk about the rest of the code. So we can say if num dot length equals to 0, return 0. If nums dot length equals to 1, then you would return not 1, nums 0. Okay, so since it was previously sorted and it was rotated to get the array that they have given us, we know that if the far left side is smaller than the far right side, then it must be the case where it is already sorted. So if you look at the example 3, left is smaller than right? That means it's already sorted. It's because when you're given a sorted array and then you rotate it, it will be a case where there will be a middle something separating two array, one where it will increment, the element will increment in value, and then it will start again, and then it will increment in that side. So I hope that makes sense to you. So basically we would have 2 sorted subarrays. So first we can take care of the part where the left side is smaller than the right side and just return the far left side. So what we can do is say let left equals 0, let right equals nums dot length minus 1. Since we are taking the first element and then the far right element. So what we can say is if nums at left is smaller than nums at right, we'll just return nums at left. But now we need to think about what to do if nums dot left is bigger than nums dot right. Okay, so first we need to figure out what our midpoint is. So once we know the midpoint, then we can try to figure out which way to go, either to look through the left section or the right section. So the way we find the midpoint is by taking the average. So it'll be let mid equals to, we'll just do left plus right and then divide by 2. But in here I would have to use mat.floor, because if I don't use that and if our array is even length, then I would get a number with decimal value, and I do not want that. I want just one strict digit without decimal numbers. So once we have figured out the midpoint, so we need to figure out if we want to do the left search or the right search, right? So in this case, what we would do is we would compare if our midpoint, which is 5 here, is bigger than the right. So if the midpoint is bigger than the right, then we know that we need to look through this part of the array, right? So in this case, in order for us to look through this part, we actually have to reassign the left side to be mid plus 1. So our mid is this, so that would be 0, 1, 2 at 2 index, and we need to make our left to be the 3rd index. So we can say if num at mid is bigger than nums at right, we would say left equals mid plus 1. So if that's not the case, we need else statement. So if the mid is smaller, like if let's say 13 is smaller than 17, then we would have to look to the left side. That means that we need to change the left index value, not left, sorry, the right index value, and the left would remain the same. So we basically have to say right equals to mid. The reason we want to include the mid, because depending on how long or short our array is, mid could be in front, right? So we want to make sure we include the mid. So at the end, we will just return nums at left. Okay, let's submit and see if this works. I had to do it a couple of times because when I was making the video, I keep saying something wrong. But anyhow, so yeah, that did end up solving it, right? So this one, it gives us n to the log n because we're effectively breaking the array in half and checking one side or the other. So that would basically decrease the amount of element we have to check in half. So that is our solution. Yeah, so if we were to just, iterate over each element of the array, that would be O of n because we are checking every single element. But in the binary search, we only check left or the right side, so that would decrease our amount of search time. So hopefully that makes sense to you guys, and I'll see you guys in the next video.